All right, fam, here we are. I'm going to do a little bit of day 3. I'm going to go through this quickly, so try to keep up. I'm only going to do, I think, 3 examples, and then we're done. We can just work in class, okay? But go ahead and start copying some stuff down. So when we're asked to graph a line, it's supposed to look like y equals, right? So what if it doesn't? Well, what I have you right here is when an equation is not in slope-intercept form, and just so you remember, slope-intercept form looks like this: y equals mx plus b. And then remember, this is like your y-intercept. That's where you start on the y-axis. And then the m is your slope as a fraction usually, and you count like up and over. Okay, so what if it doesn't look like that? Well, what do you think? We just have to get the y by itself, so we have to like move things over and solve for y. That means get the y equals all by itself. So I'm going to do that for example number 1. I'm going to start by moving this 2x over to this side. And how do I, because I'm trying to get y by itself, right? I'm trying to get y equals. So I need to move the 2x out of the way. So I'm going to subtract both sides by 2x. That cancels it, and I have negative 3y equals. And these are not like terms. This is a whole number, and this has an x. So I'm actually going to leave it as negative 2x plus 12. It's a negative 2x because I subtracted the 2x over, and it is a positive 12 here, which is why I wrote plus 12. You cannot combine those because this is an x and this is a whole number. So now next thing I need to do is I need to still try and get y by itself. It's being multiplied by negative 3 right now, so I need to divide everything by negative 3. That cancels my negative 3's. I know what you're thinking from last chapter, that since we divided by a negative, we would need to flip our inequality symbol, but this is not an inequality symbol. This is just an equals. But I know a couple of you probably might have been thinking about that. Anyway, so did you know that a negative divided by a negative is a positive? So that just leaves us 2 over 3x. And then positive 12 divided by negative 3 is actually negative 4. So that equation, this one right here, is the exact same as this equation right here. They're just in different forms. So this one didn't have y by itself, so I like moved a bunch of stuff around and got y by itself, and now it equals this. And I'm pretty sure you know exactly how to solve or how to graph this. So remember, you start on negative 4 on the y-axis. This is always the y-intercept. That's why this is called a y-intercept. So I'm going to find negative 4, which is right here. And my slope is 2/3. What that means is I'm going to write up 2, right 3. So both of these numbers are positive. So the 2 means up 2 because up is the positive direction. And the 3 means right 3 because right is also the positive direction. So I'm going to go up 2 over 3. Up 2 over 3. Yes, you can also go down to left 3. And that makes your straight line. And we are beautiful. Okay. I'll leave 2, 3, and 4. But what I want to look at now is the back page. I'm going to change these directions around just a little bit. I really just want you to be able to look at an equation that's been graphed like so. Figure out what the slope of the line is. And the point, I want you to be able to identify the y-intercept, so where it touches the y-axis. So in this case, it would be right here. And then we're going to write the equation, and that's going to be pretty quick. But what I want to do first is I'm going to zoom in on this graph. And remember, I want 2 things. I need the y-intercept, and I need the slope. And so the y-intercept, remember, it's called a y-intercept for a reason, right? This is the y-axis. So I need to figure out where my red line touches my y-axis, which is right here. I'm going to put a dot there. That is my y-intercept. It happens to be negative 2. Okay, so that point right here on the y-axis where the line touches the y-axis is negative 2. This is 0. We go 1, 2. That's my y-intercept. Now, can you figure out what kind of slope this is? It's going up, right? So this is going to be a positive slope, and I just need to count how far up do I go and how far over do I go every single time to get the slope. So in this case, I'll zoom in here. It looks like we're going up 1, 2, and right 1. Up 2, right 1. Up 2, right 1. So in that case, that means that my slope is 2 over 1, which is 2. 2 divided by 1 is 2. And so that is what I'm going to put over here. My slope is 2 over 1, which is 2. My point I'm going to use is my y-intercept, and that was negative 2. So I'm going to skip this point slope. We'll get to that a little bit later. But the equation in slope-intercept form, do you remember what slope-intercept form is? It's y equals mx plus b. The m is the slope, and the b is the y-intercept. So hopefully you're like almost rolling your eyes now and being like, oh my gosh, we've done this so much. I already understand this. Okay, that's great. So my y-intercept, the b, is going to be negative 2. My slope, the m, is going to be 2. So I'm literally just going to write y equals something x plus something. I just have to fill in the slope and the y-intercept. So remember I said the y-intercept was negative 2. That's what goes right here. That's the b. So I'm going to put negative 2. Remember what the slope was? It was 2. That goes here. So another way of writing this is y equals 2x minus 2. Because you know plus a negative is the same thing as minus. That just means you start on negative 2. All right, so let's take a look at one more. I'm going to go down to 7, and let's start with that one. So I want to zoom in on the graph. Remember, I want to first figure out what's my y-intercept. So where does the line touch the y-axis? It touches right down here. That would be negative 7. Negative 7. Let's figure out the slope now. So I'm going to put a dot on negative 7. That's my y-intercept. And it looks like I'm going up 2 over 1, up 2 over 1, up 2 over 1. Yes, you're also going down to right 1. And so can we figure out here, let's just take a step back, look at this graph. Here's the line. Is it a negative slope or a positive slope? This one's going down. So we've got a negative slope. So that means if I go up positive 2, left 1, that would take care of the negative. The up 2 is positive and the left 1 is negative. And when you make a fraction out of a positive and a negative, you get a negative. Same exact thing as if you go down 2, that would be a negative 2, and right 1 would be a positive 1. So again, either way, we have one positive direction and one negative direction, which gives us our slope of negative 2. You can put negative 2 over 1 if you want, or you can just leave it as negative 2. It's the same thing. So again, I'm going up to left 1, so this would be positive 2 divided by negative 1, which gives us our negative, or you could go down to right 1. That would be negative 2 over 1. Same thing, we get a slope of negative 2. So remember my slope, I got negative 2, same thing as negative 2 over 1. My y-intercept was negative 7. So I'm going to not do the point slope form again. We'll get to that later this chapter. I'm going to just go right into slope intercept. So remember what slope intercept is. Y equals mx plus b. And I have to plug in my slope and I have to plug in my y-intercept. So the slope was negative 2x. And my y-intercept was plus negative 7. And yeah, you don't have to have the plus negative 7. You could write the same exact thing. Either way, this just tells you to start on negative 7, which is right here. Start on negative 7, which is right here. And this negative 2, you could write it as negative 2 over 1 if you wanted to. But that is how you write the equation in slope-intercept form, okay? Love you guys. Let's do a couple more in class, okay?